Hello and welcome to Easy Projects. Today we're going to take a look at how to test laptop batteries. Well, I know this one is bad because it can only run the computer for about 10 to 15 minutes when I unplug the charger. But it could be that you don't know if your battery is good or if you bought a new one and you want to check if it lives up to its specs. And there is a little trick you will need to do with these laptop batteries in specific, but you might already know that, so let's get on to it. So on this battery they have been so kind to show us where the positive and negative terminals are. But that is not common, so we just got lucky here. But the problem is that when you try to measure the voltage with a multimeter, and we make sure to plug the leads into the correct holes here, pretty much nothing will happen. And that is because in most laptop batteries there will be a safety feature that you will need to pull one of the other pins to ground before the output will be on. And that will work both for charging and discharging. And you can try to look up your battery on Google and see if there's a pinout. In my case there wasn't, so I have to figure it out myself. And it turns out it's actually not that difficult now that we know where the positive and negative pins are. So let's take a look at the male connector in the computer. And here is the connector. And the first thing you should notice is that these two pins over here are actually larger than the rest of the pins. And they are both wider and longer as well. So they obviously wants to make sure that these two pins makes contact first. And you would be able to say with about 99% certainty that this will be the ground pins. And that also matches with what's written on the battery. So my computer is an Asus, but also in this HP they have done the same trick, even though there's only one pin here. But it is slightly longer and wider than the other pins. So now that we know that these two pins over here are ground, it should be fairly easy to find anything at the same potential. Let's just try to measure the resistance between some of the pins in here. If we take the first two, that should be ground, and that's showing 0.2 ohms. So, and take the next one, 116k, next one, 24k, next one, 24k, the next one. Oh, there's something. That is 0.18 ohms. So that is definitely a ground pin. The next one. That is also a ground pin. The next one. That is 18 kilo ohms. The next one. That is an 8 meg. And the last one is 5.6 meg ohms. So pin 3 and 4 from this side over here was also at ground potential. So let's try to take a look at the battery again. And now, since we know that the two pins on the male connector are connected directly to ground, there should be nothing wrong with just using a wire, but you could use a resistor or something if you want to make sure that you're not blowing anything up. So let's try pin 3 here. Nope, that didn't do anything. Pin 4. And there we go. Now it's showing 11.94 volts on the multimeter. And it will now allow us to draw current from the battery. So now we just have to set up a test to measure how much current is in this battery. Well, we could of course just draw some current from the battery by hooking up a power resistor. And then measure the current over time. And that will look something like this. And then we'll just have to find the area under the curve here to find the total capacity. But it turns out that will not be so easy, because then we'll need to sample all these points here and see if we can find any function that will describe this curve and take the integral of that one, and that could give us the area that we are interested in. But if we, instead of using a resistor, used a constant current load, we could have a current versus time curve that will look like this. And now we can just take one sample of the current and multiply it by the time, and that will give us this area here that we're interested in. And one way to do that is still to use a power resistor, but then add a MOSFET or transistor before that, and control that transistor by an op-amp. And we then give this op-amp a reference voltage. If this is a 1 ohm resistor, we could give this a 1 volt reference, and that will mean when this node here is at 1 volt, this transistor will allow 1 amp to pass through it, and the op-amp will make sure that these two match, so this should work. And I have built this constant current load here that will do exactly that, except that the reference for the op-amp is adjustable, so I can set any current that I want. I have already mentioned this in a previous video, but these loads are very handy, and if you want to learn how to build one, I am planning to make a video soon. And I guess I also said that before, but I never came around to it. And also go and check out EEV Blog's YouTube channel for a guide on how to make one of these. He made a very nice video about it. But since I know that the old battery is bad, I already went and purchased a new battery. And I bought this one on eBay, and it was pretty cheap, so I'll just test this as well to see if it meets its spec. I am ready to do a discharge of the old battery, and I'm using my constant current load here, but I really need to build a new one of these because it's not designed for higher currents. So I'm discharging it at 1.5 amp, and I really have to use a fan to ensure that the load will not overheat. So I'll just hook up this wire and start a timer, and we will see how long it takes to discharge the battery. And we can calculate the total capacity when we have finished discharging. So now that we are done with the testing, we can calculate the total capacity of the two batteries. And I said I was discharging them at 1.5 amps, but I measured that with the multimeter and it was more like 1.45 amps, so I just corrected that in the calculations. So the old battery lasted for 0.5167 hours, and multiply that by the 1.45 amps. We will get 749 milliamp hours. So that could be why it doesn't last that long when it's fully charged. The second battery, the new one, lasted for 2.63 hours, and that will give a total capacity of 3.81 amp hours. It is rated for 5.2 amp hours though, so it doesn't quite meet the spec, but it was cheap. So I kinda expected that, but the original battery is also rated for 5.2 amp hours, but I'm sure that will meet its spec if I had bought one of those, but it cost about 6 times the price of the non-original one. So I hope that was useful if you will ever have to check one of your batteries. Thanks for watching this video, and if you like it, please give it a thumbs up and subscribe to my channel. See ya!